Now, we're going to evaluate each of these, and the way that we're going to do it is using our definition and changing these from logarithmic form to exponential form. The first thing that we're going to do is we're going to say that what we're trying to solve for is equal to x. Now, on your final exam, if you add a variable without properly introducing it, it's one of those errors that's a half-mark deduction. So all you have to do is say let, and then you're fine. So I'm going to let x equal this. I want to evaluate that. So by saying let x equal that, if I solve for x, I will have evaluated what I want to. Now that I have this, well, this is the form I'm not comfortable with. I can change it to exponential form. The base is 5. Log solve for exponents, so the exponent is x equals 3125. And I think on our powers chart we didn't even go this high. I think for powers of 5 we went up to 625. This is the next one. 3125 is 5 to the 5. So once we get 5 to the x equals 5 to the 5, this is our same technique that we used yesterday, where if we can get the bases the same on both sides, once the bases are the same, then these exponents need to be the same. So we can tell from here that x has to equal 5. So you could even write your final statement that you now know that log 5 of 3125, you've evaluated it, it's equal to 5. For our second one, again, I'm going to let x equal log 6 of 1 over 216. So that lets me say my base is 6, my exponent is x, my answer is 1 over 216. Is that on your powers chart for 6? It is. 216 is 6 cubed. What exponent law can I do on this side to move that up? I can make it 6 to the negative 3. Therefore, x equals negative 3. And we just figured out that log 6 of 1 over 216 is equal to negative 3. Our last example is a little bit more difficult. But again, we're going to let x equal that. Same idea. And change it to exponential form. 2 cube root of 2. Think of your powers chart. Is there a column? Is there a base where all of those numbers can be written as? Well, these ones are already 2s. That's pretty low. Can you write 8 as a power of 2? Yes. So this is 2 cubed to the x. 2 is 2 to the 1. And the cube root of 2, I can change it to 2 to the 1/3. What's our exponent law on the left-hand side? Power to a power? Multiply, so you get 2 to the 3x. What's your exponent law on the right-hand side? The bases are the same, and you're multiplying. Can add. In order to add fractions, I need a common denominator. Are you okay if I change the 1 to 3 over 3? So 3 over 3 plus 1 over 3 would be 2 to the 4/3. At this point, your bases are the same, so these exponents have to be the same. So 3x would equal 4/3. And to solve for x, I'd have to divide both sides by 3. Dividing by 3 is the same as multiplying by 1/3. So I get x is equal to 4/9. Now, when we get to our quiz on this section, which is not on Friday, but when we do 5.4 to 5.7 quiz, you're going to get questions like this on your pre-quiz. I'm going to tell you right now that your textbook if you look at the solution on the side, and your the computerized program, if you choose the help me understand this or show me an example, they will do it in a slightly different way. I like this method because it connects to the same method we did in 5.3. Okay? If you want to know how they did it, you can look. Sometimes their method works really well. At other times, I think it's confusing. And so I like this because it's similar to what you've already learned and allows you to do one thing twice. You can use the same basic method for solving two different kinds of questions, which is really nice. You can look at their method and you'll see it when you do the pre-quiz, but if that's confusing for you, I would recommend this, especially for our last example here. The method in the textbook is a little bit confusing for the harder one. But I'd like you to practice some of these right now. We still have over 10 minutes left. 4, 7, and 9.